Island Park Dam has 3 outflow points. You can see 2 of them when you're downstream of the dam looking back up like we are now. One is on the west side or left as you're looking up, that's the gates, and you can see water coming out of a tunnel. On the other side, on the east side, you'll see a building, that's a power plant. Water comes through the plant, goes into an aeration basin, and then flows out into the river. The third outflow point you can't see from the front. We have to go around to the back of the dam to see that. Okay, here we are on the upstream side of the dam, and we can see the third outflow point, which is this concrete thing that looks like a bathtub, and we call it a bathtub, but it's actually the spillway. If the reservoir were over full, water would spill over the top of that bathtub lip and into the spillway. Okay, let's talk about what happens when Island Park Reservoir gets filled. So the reservoir holds 135,205 acre feet. An acre foot of water is a football field, roughly a foot deep. And to get that amount of water in the reservoir, the water surface elevation has to be 6,303 feet above sea level. And that's roughly 30 feet below the top of the dam. But the top of the concrete spillway is only at 6,302 feet. So when the reservoir gets to 6,302 feet, it's not full yet, but it starts to spill over the spillway. So how do you get that last foot? Well, you have to let the reservoir fill, what we call surcharge, up to 6,303 feet. But then what happens is a whole bunch of that water is spilling through the spillway. This worked fine before there was a power plant, but once the power plant got built in the 1990s, this is water that could have generated power that essentially was lost to power generation because it was spilling over the spillway. So the solution was to install a 1-foot rubber dam on top of the concrete, inflate it when the reservoir gets near full, and then you can still get it to 6,303 feet and full pool. But now, instead of spilling, the water can be directed through the power plant where it can generate hydroelectric power. Okay, so now we know the 3 outflow points from the dam, and we know how the reservoir gets filled. So here it is full. It's not spilling any water. The 1-foot rubber collar is inflated, and we got a full reservoir. Let's look at the other 2 outflow points now. The siphon that takes water to the power plant sits about 60 feet deep below the surface of the water when it's full. And then there's the gates that are even a little deeper, 73 feet down. That's where water is at the deepest point in the reservoir. Okay, so now let's say we're midway through the summer, so the reservoir's not full anymore. Maybe it's right here. What happens at that point is we don't need the rubber collar anymore. So that thing gets deflated. It's not even in the picture anymore. And now water can either go through the gates or into the power plant siphon or some combination of both. Now let's think about this. Even though these depths are relative to a full reservoir, still the gates are deeper in the reservoir than the power plant siphon. So this water is likely to be a little colder here than here because it's coming from a deeper portion of the reservoir where cold water has settled out at the bottom. But this water is likely to be a little dirtier because it's drawing right off the bottom of the reservoir, whereas this water is cleaner because it's drawing from, maybe 12 feet up off the bottom. Okay, so now we know that to get the reservoir to full pull, we have to inflate this 1-foot rubber collar to allow control of that last foot and let the reservoir fill. But oftentimes the reservoir is still covered with ice as the reservoir level is approaching that rubber collar. The rubber collar can't be inflated while there's ice on the reservoir, so there's actually an additional constraint that the reservoir can't get any higher than 1 foot below full until ice melts. On average, that's in the last week of April or first week of May, so we can't really even deal with that last foot until that time.